Okay, so in this video we're going to work on some problems from the practice test, and I'm going to only work on the problems that don't have graphs. For the graphs, you can look at the answer key, and if you have any questions you can send me an email. So if we look at number 4, it says f of x equals a quantity x minus 4 cubed times 2x cubed plus x quantity squared. And so in this case we're multiplying two functions together, so this and this. Though it's a little confusing because this is our f of x, I'm going to call this f and I'm going to call this g, so we can use the formula fg prime equals fg prime plus gf prime. All right, so what we're going to get in this case is the first function, which is x minus 4 cubed. And then for the derivative of g, we're going to have to use this thing, the extended power rule. All right, so that's going to be times 2 times 2x cubed plus x to the first power. All right, and then we're going to multiply that by the derivative of the inside, which is 6x squared plus 1. All right, so the extended power rule says that we take this exponent and we move it out in front and then bump it down by 1. And then we multiply by the derivative of the inner function, and the derivative of 2x cubed plus x is 6x squared plus 1. So then what I'm going to do is I'm going to write my second function, which is 2x cubed plus x quantity squared. And I'm going to multiply that by the derivative of the first. So I'm going to move the 3 down in front. And then I'm going to do times x minus 4 squared, because I bump the exponent down by 1, and then I can multiply it by the derivative of the inner function, which we could say is just 1. And so if we wanted to, we could rewrite this as 2 times x minus 4 cubed times 2x cubed plus x times 6x squared plus 1. And this we can rewrite like this, and then I'm going to pull the 3 out in front, so I have 3 times 2x cubed plus x quantity squared times x minus 4 squared. And this is going to be, if we switch these two around, remember on the old exams, sometimes they switch the order of the two functions in the product rule. So this one actually appears first on your practice test, and this one appears second. So this is going to be answer choice D. All right, so let's look at the next one. Let's say that we have, in this case, number 5, and we have y is equal to the natural log of 2x squared minus 4e to the minus x. And so if I want to find dy dx, what I'm going to do is I'm going to move the 2 out in front, and that's times the natural log of 2x to the first. And then I'm going to multiply that by the derivative of the inside, which is a natural log of 2x. And if you remember, we had a rule that d dx of the natural log of cx is equal to 1 over x, with cx greater than 0. Okay, so the derivative of the natural log of 2x is just going to be 1 over x. So I'm going to do the extended power rule. I'll move the 2 out in front. I'll bump this 2 down to 1, and then I'll multiply that by 1 over x. And then over here, remember we have this formula d dx of e to the f of x is equal to f prime of x e to the f of x. All right, and so if I do that, then I'm going to move the minus out here, and that's going to give me plus 4e to the minus x. All right, so in this case, that's going to be answer choice B. All right, so for number 6, we have the integral of e to the minus x plus 1 over pi dx. All right, so what we want to notice here is this 1 over pi is just a constant. All right, so we could write this as the integral of e to the minus x dx plus the integral of 1 over pi dx. All right, and then also you should remember we have a rule that says the integral of e to the ax dx equals 1 over a e to the ax plus c. So in this case, our a is going to be basically this negative sign, so a negative 1. So I'm going to get 1 over negative 1 e to the minus x. I'm just going to put my c at the end, and then I'm going to say that this is a constant. We have the integral of k dx equals kx plus c. All right, so this is 1 over pi is our constant, so we're going to multiply that by x, and then we'll just combine our two constants of integration into 1 at the end. So this over here is going to be, if I do 1 over negative 1, this is negative e to the negative x plus 1 over pi x plus c. All right, so this is going to be answer choice D. All right, so for number 7, we get the integral of 2 times the cube root of x minus 1 over x plus the square root of 20, and this is dx. All right, in this case it says x is greater than 0, because that'll make sure that the domain of the natural log turns out to be okay. And so what I'm going to do here is I'm going to rewrite this as 2 times the integral of x to the 1/3 dx minus the integral of 1 over x dx plus the square root of 20 dx. All right, so now I can do the rules of anti-differentiation. So for this one here, I'm going to use a power rule. So I'm going to do 2, and my x, I'm going to add 1 to the exponent, so I get 4/3. So I'm going to do 1 over 4/3 out in front. Then here I have minus the integral of 1 over x dx, and remember we have a rule that says that's the natural log of x when x is greater than 0. Okay, and then again here we have a constant, so we can say this is plus the square root of 20x plus c. So here we simplify this a little bit more. This is going to be 1 over 4/3, we'll call 3/4, and that's x to the 4/3 minus the natural log of x plus the square root of 20x plus c. So this over here is going to be 6 over 4, which is 3/2 x to the 4/3 minus the natural log of x plus the square root of 20x plus c. All right, so again, this is just applying the rules of anti-differentiation. So you should make sure you know the power rule for anti-differentiation. You should know the special case when it's x to the -1 or 1 over x, so that's going to be the natural log of x when x is greater than 0. And again, here we have a constant k. So we have the rule we saw on the previous page, which is this is kx plus c, the antiderivative. So in this case, we get the square root of 20x, and then we just add all the constants of integration to the end. Okay, so the next problems, 8 through 9, are in a graph. So you can work on those and look at the answer key and see what, if you have any questions, you can email them to me. Otherwise, the next video will continue with more problems from the practice test.